Math 50, section 9.3. This section is all about the area, the volume, and surface area of different polygons. So we're going to use formulas for this section. You have to study and memorize them. Let's just review some of the ones that we're really familiar with and get into some ones that we're not so familiar with. So we have, first of all, area. What is area? Area is the space inside of a plane. Okay, so if you have a rectangle, we have the width of a rectangle and the length. The space inside is the area would be the length times the width, and that one we're very familiar with. And the area of a square is each side multiplied by itself, so side squared, so side times side. So think of rectangle and square as basically the same thing. You're multiplying two sides together. Okay, a few that you need to also know are the area of a triangle. It's the base of the triangle times the height times a half. It's a half base height. And the reason it's a half base height, the base and height, think of that as if you had a rectangle, the base and the height would be the length and the width. Half of it, the reason you're cutting that in half is because you're only, a triangle is half of a rectangle. That's what it is. A parallelogram is just like a rectangle. It is a rectangle, but the two sides, the widths are slanted. So it's base times height. We use the word base for length and height for the width. So think of this as just like a rectangle, base times height. A trapezoid, where two sides are going in and we have two sides that are parallel. What you're going to do is you're going to add the bases, add these up, you're going to multiply it by the height and then cut that in half. So it's 1/2 times the sum of the two bases times the height. An area is always in units squared. Perimeter was just in units. Area is units squared. So here's our first example. We're just going to apply these formulas to figure out what they're asking you for. So for this one, we've got the area of a triangle. An area of a triangle is 1/2 times the base times the height. So we have 1/2, the base is 14, and the height is 8. Now, when you're multiplying, you could do a couple things. You could multiply across and then multiply down. So this would be 14 times 8 and then divided by 2. Or what you could do is say, reduce this. 2 goes into 14 7 times, and now that 2 is gone. So 7 times 8 is 56. So this triangle is 56 centimeters squared. Okay. Example 2. Finding the area of a parallelogram. Very easy. The area of a parallelogram. Think of this as a square. Think of this as, it started off as a square, and let's pretend like these two sides were both slanted. If this was slanted here, and then this would be slanted like that. So anyways, that's a parallelogram, and all that, the area of that would be base times the height. So the base is 3.4 and the height is 1.5. And if you just multiply those out like you did without using a calculator, this is the way you do it. 5 times 4 is 20. 5 times 3 is 15 plus 2 is 17. Put a 0 there. 4 times 1 is 4. 3 times 1 is 3. And add. And you get 51, and move your decimal two places over, so it's 5.1. And this is in miles, so it's miles squared, or square miles. So this answer is 5.1 square miles. Okay? Example 3. All right, this is like that one problem we did with the perimeter where they don't give you all of the sides. So if you are trying to find the area of a space that's not completely rectangular or it's not a triangle, you have to break it up into two parts. So let's recreate this picture the best I can here. So I see two rectangles here. If I break this up into rectangle A, so if I were to move this, make a invisible line there, and then this one would be B. So we have A and we have B. Okay, so we need length times width. So this we know is 4 and 8. So the area of this 4 times 8 is 32, and it's square feet. Okay, so area A is 32 feet squared. Now B, we know that this side is 12, but we weren't given this side, okay? We were not given this side. So if this is 12 and this is 4, what you're going to do is subtract. 12 minus 4 is 8. So this would be 8 feet right here. This side is 8 feet, and we're given this side is 5 feet. So the area of this rectangle B is 8 times 5, which is 40. And so to find out the total area, you're just going to add these up, and you get 72, and it's square feet. Okay. So here's another, this is a good problem. Here's another example. I'm just going to go over it quickly. So actually, no, this is the same one. It could have been split differently, rectangle 1 and rectangle 2. So you could have done 12 times 5, which is 60, and then add that to 4 times, you'd have to figure out this side, or actually I should say this side, which if this is 8 feet and this is 5 feet, this would be 3 feet. So 4 times 3 is 12. So 4 times 3 is 12, and then add that to 60, and you'll get the same answer. Okay, area of a circle. Here's a little application to hopefully you'll understand it, if you choose to understand how this comes into meaning, this formula, which is going to be pi r squared. The area of a circle is pi r squared. Now don't get that confused with perimeter. Perimeter or circumference of a circle is pi times d, or 2 pi r. So if you look at this circle, this half of this circumference right here is pi r, and then you have another one, pi r. So if we were to take this circle and make it into, it looks like teeth. This lighter taupe color is this top part, and here's the bottom part, pi r. If we were to move these two teeth together, so this side is pi r, and the obviously the radius is here. So length, think of this as length times width, and if you did pi r times r, that's where you get pi r squared. So the area of a circle is pi r squared. We're going to use pi r squared for the area of a circle. Now for a circle, when you use pi, either use 3, you can leave it in pi, you can use 3.14 or 22/7 is the equivalent of pi. So let's, we are looking for example 4. Here is example 4. So now we're going to find the area of this circle. So the area is the space inside. So if the radius is 3 feet, area is pi r squared. So it's pi times 3 squared. In order of operations, you always do exponents first. So this is 9 pi. So you can leave your answer as 9 pi, or you might see it as if you multiplied it out, you get 9 times 3.14 is 28.26. And don't forget, you want to put the units in there. Whoops, not that, sorry. It's feet squared. So either one, square feet, leave pi there, or you can multiply it out. Now we call, when we leave pi in the answer, just, you're gonna see this in the upcoming classes, an exact answer is when pi is in the problem. This is estimated because there's a decimal involved in a lot of rounding, so you chopped up part of the answer. So believe it or not, an exact answer would be 9 pi. So anytime they ask for an exact answer, do not multiply it out. It's actually easier. Okay. The last section is a little bit more complicated, and it's the volume and surface area of solids. Okay, there's a lot of formulas in this section. I'm going to simplify it the best I can. So what you have is a figure, and in this case, looks like maybe a shoebox. The stuff inside of a shoebox, what you put in a box, is called the volume. It's the space inside. So all of the stuff to fill this is your volume. But if you were to take this box and wrap it in wrapping paper, that's surface area. Okay, volume is what's inside. Surface area is finding all of the areas and then adding them together. Okay, so that's basically it. Here are the formulas for surface area and volume. So you have to know which figure you're working with. So if it's a rectangle, and the difference between a rectangle and a rectangle, the width, height, and length are different units or different numbers. A cube, all three sides are the same. So basically it's the same formula. It's just easier when it's a cube to just use the side because it's the same, and you can do it that way. So volume of a rectangular box would be length times width times height. Length times, so you're just multiplying all three sides. Length, width, height. Surface area, that would be like how much wrapping paper. What you want to do is look at this figure. Okay, so you have two of these. So think of like a box. There's two of these sides. So it's 2 length times width, let's say. So 2 of these. So think of, you're finding the area of one of the squares, but there's 2 of them. Okay? Okay, then we're going to continue. You've got these 2 sides, the sides. Okay? So this would be 2 times the width times the height, let's say. So this and this back side right here. And then you have the top and the bottom of the box, which would be 2 length, height. Okay, so really you're finding there's 3 different areas, but there's 2 of each of those different areas. So you're adding them all together. So the volume of a cube is each side times itself. So side times side and times side is side cubed. Surface area would be figure out one of the areas, side times side, and then there's 6 of them. So 6 times side squared. A sphere, the volume, which would be what's inside, is 4/3 pi r cubed, where the surface area is 4 pi r squared. A circular cylinder like a can, the volume is pi r squared h, and the surface area is 2 pi r h plus 2 pi r squared. You just got to know what the height is, what the radius is. If they give you the diameter, you just cut that diameter in half, and that's what your radius would be. A cone, think of an ice cream cone. The volume, how much ice cream's in a cone, is 1/3 pi r squared h. And the surface area, and you're not expected to know these 2 formulas, Surface area is pi r square root r squared plus h squared plus pi r squared. And a square-based pyramid, which I'm trying to think of something that's square-based pyramid. I'm not quite sure right now off the top of my head, but I'm sure there's lots of figures out there, but volume is 1/3 s squared side squared, okay, because it's square. It's the side squared times the height, and it's 1/3. So think of this as it's really a cube, but if it's a square base cube, it's 1/3 of this. So what you could do is do 1/3 of that. That's what use that formula. And actually, no, you can't, because it's not, the side might be different than the height. So just use this formula, 1/3 s squared h, and then surface area is the base of the square pyramid, plus a half the perimeter of the base. You'd have to add up all the sides, and the height, the length would be the slant height right here. You have to know that. So if you get into geometry, you'll work more with these formulas, but for this class, it's just a matter of taking the formula. It's like these are recipes, taking the formulas and knowing what the side is, what the radius is, what formula to use, and know how to do the math involved. So let's look at some examples. Example number 5, it's asking you, read it carefully, it wants the volume and surface area of this rectangular box. Okay, so volume, when you have a box, you're looking for what, how much space is, how much is inside the box. So volume is equal to length times width times height. So we have this box, it's 12 inches in length. The width is 6 and the height is 3. You're simply multiplying these three numbers together and you get 216. And make sure all units are in the same. If they're not, you're going to have to convert. That's another section. But this is inches cubed. So that's how much is in there. But now surface area of this, you're going to take 2 of the length times the height plus 2 of the width times the height plus 2 times the width times the length. Now, if you wanted to, you can just simplify this and you're going to multiply 2 of these, so 12 times 3, and then double it times 2. Take 2 more, multiply them together times 2, and then the other 2, 6 times 3, multiply it, double it. That's all you're doing. So 2 times 12, we're just plugging these numbers in. And don't get so worried about plugging them in the right spot. Just as long as you multiply them each together, it doesn't matter what order you do it. So really all I did was I did these two numbers, so this is the area of this side right here, but there's 2 of them. So 2 times 12 times 3 is 72. Then these 2 back sides, which is going to be 36, and the other 2, which is 144. And if you add them up, you get 252. And this is going to be in inches squared. So make sure you understand, perimeter is in units, surface area is in inches squared, area is always inches, units squared, and volume is in inches or units cubed. Okay, what about this is asking you, let's say you have a basketball and you want to find the volume. Okay, so volume of a sphere, volume is equal to 4/3 pi r cubed. Okay, so we know 4/3, we know pi, and we have to pull out the radius, which is 2. We have to cube it. Okay, now you could easily, there's different ways. You have to really understand when to use pi and when to use 3.14, when to use 22/7. In this case, I'm gonna do both. 2 cubed, you always do exponents first. 2 cubed is 2 times 2 times 2, which is 8. okay? Now, if I multiply across, I get 32 pi, and then that's all over 3. So this is an exact answer. So if they ask you for an exact answer, that's it. Now, you could have also, instead of, if they don't want you to use pi, pi is 22 over 7. So if you multiply 32, I'm just going to use my calculator, 32 times 22 is 704 over 21, okay? That's another possible answer. Or you can take 704, you can divide it by 21 and get an estimated 30, this is approximately 33.52, and remember, it's in units cubed. So there's different variations of the answer, okay? For the surface area, surface area is, for that surface area, and we just abbreviate SA, those are my initials, 4 pi r squared. So it's 4 times pi, and it's the radius squared. 2 squared is 4, 4 times 4 is 16. 16 pi is one good answer, that's an exact answer. And then if you multiplied 16 times pi, you get 50.24. Okay? So that's also, and make sure it's in inches squared because it's surface area. So that would be like the material that they use to cover the outer of the sphere of a basketball. Okay, example 7, we have a can and we're looking for two things, the volume, and I think that's all they want for number 7 is the volume. Find the volume of a can, yes. So volume of a cylinder is pi r squared h. So pi, we know that. This radius is 3.5. So 3 1/2. We're going to convert this to a fraction. 3 times 2 is 6 plus 1. This is 7 over 2, but we have to square it. And the height is 6 inches. Okay, and again, make sure your units are all the same. So when we square a fraction, we square both the numerator and the denominator. So this is 49 fourths. 7 squared is 49. 2 squared is 4 times 6. Okay. So we can multiply. What we could do is simplify. 2 goes into both of these. Okay. So now when we multiply, it's not as much, or you can just go ahead and 49 times 3 is 147 over 2, and then we have a pi. And remember, it's in units, so this is in inches, cubic inches. So you can leave your answer like that, or you can divide it out. 147 divided by 2 is 73.5 pi, or you can do 73.5 times 3.14 to get an estimated 230.79, and that again is in inches cubed. Always volume is in units cubed. Okay, and I believe this is the last example. We have a volume of a cone, and the volume of a cone is 1/3 pi r squared h. You just have to know how to use this formula. So we know the 1/3, that's going to stay pi. The radius is 3. Now if they gave you the diameter, make sure you cut that in half. So 3 squared, and the height of this is 14. Okay. Now, if you have 2 of these 3's being multiplied and you have 1 here, you can cross one of them out. So really you're multiplying 14 times 3, which is 42. and then times pi. So the volume is 42 pi, and again, it's in centimeters cubed. Now, if you want to take pi out, you're going to do 42 times 3.14, and you'll get 131.88 centimeters cubed, or cubic centimeters. Make sure you label. And that's the end of 9.3.